Hello everyone. So again we are back with the daily Leetcode practice questions. So let's start with the first problem, middle of the linked list. So this is one of the easy problem that we will be solving today. So the question is pretty much clear and simple. We are given with a singly linked list, and we have to return the middle node of the linked list. Let's say if we have two middle nodes, then we have to return the second middle node. So let's say for an example, we have a, a linked list, and if this linked list, if the number of nodes are odd, then we are returning just one middle node, that's 3. And if we have like even number of nodes, then we are returning the second middle element, that is 4 over here. So the question is pretty much clear and simple. I guess everybody got the gist of the question. So do you have any questions regarding the problem statement? Anyone? Yeah. So I think the question is pretty much clear. And so can we discuss the approaches that we have, like different approaches? Anyone who wants to come up with his or her own approach?
Hi, so Tanmay this side.
Yeah. Hello, Tanmay.
So what I did in this question was just a simple approach that I traversed the linked list, and I had three parameters. I had one uh, middle node, one boolean flag, and a temp node. So actually, temp node was equivalent to head node. What I did was I kept my boolean false, and then when my boolean was false, I moved both mid and the temp node forward, and then I made my boolean true. And if in case my boolean was true, I moved only the temp node forward. This way, every time I encountered an odd node, like when the size of my linked list was odd, so at that point of time, I was my mid element was every time at the middle node, and when the size was even, then at that time my middle element was at every time at the right position. So basically, I traversed till array dot length is not equal to null. मतलब linked list connects is not equal to null, and I got the answer.
Yeah, I also did in the same way. Like I had a temporary pointer, and then I just used a counter variable, and if the counter variable was odd, then I just incremented the mid by 1 and moved the pointer by 1. And if it was even, then I just did nothing, and I just incremented the count value, and I moved the head pointer one step further. So anyone?
Okay. I would like to give a suggestion.
Yeah.
You're using count mod 2 not equal to 1, right?
Yeah.
मतलब whenever we have to divide every time, always try and use the bit
Yeah,
manipulations.
yeah, yeah, yeah. I know that,
Yeah.
but I generally prefer this because it's more understandable than that. Just for my purpose, I do that.
Okay.
So can you tell me how the bitwise is more efficiently? Is it just for
Uh,
faster or faster purpose or
it's much more faster than the
okay,
modular sign and divide sign.
okay, okay,
I posted a simple. It was a simple question. I just used bit manipulations on Leetcode only. So my answer was 2 milliseconds faster than 100% of the Java submissions.
okay? I
And
will
the
make
question
sure
was
that I will use bitwise operators.
yeah, that's
Okay. So, are there any other approaches like we can discuss for this
Yeah,
question?
so one approach which I followed is to use just two for pointers. Every time the loop runs, or you just take one of the pointer which will run two steps and one pointer which will take one step. So the concept of fast and a slow runner. So at every step, you will run the slow pointer as just a single step because it's half, and the fast pointer will run the two steps. And at the end, what will happen when you are crossing the boundary of the linked list, your slow runner will automatically be at the middle position.
Yeah, fine. I guess it's much more faster than our
So,
approach because
Ashish, I
yeah,
have
it will
posted
take
the link
n
to
by
the code
two.
if you mind opening
I
it
have a doubt.
from the Leetcode, from the Slack.
Yeah, sure.
I have a doubt. What if the size of linked list is just 1 or 2?
Yeah, if it's one, I guess.
No, no,
Yeah,
no,
the
no, no.
constraint
Not
is
in the
between one or
question.
two.
Not in the question. Not in the question. In the approach that our fast pointer is moving two
Yeah,
steps
I
ahead.
guess for two it will work because if we are in starting from zero, then if we just move the slow pointer one and then we move the other pointer by two, then I guess we reach the end of the linked list. So we will be pointing to the middle of the element.
Hey, Ashish.
Uh, yeah, hello. Yeah,
Okay, there could be a case. It's not
Hello.
here, but hello.
yes, please go ahead.
Okay. What if the linked list is empty? Well, it's generally not a case, but in HackerRank, most of the question it has a case in wherein the
Yeah,
linked list is
for this, I
empty.
guess it is mentioned 1 in 100. Like number of nodes
Yeah,
is
yeah, yeah.
from one
Okay,
to
okay,
100.
okay, okay, okay. Cool.
I mean, for both, for any of the solution, right? If linked list is empty, that also should work, right? For fast and slow pointer, also it should work.
Yeah, it will work. So I guess the slow and fast pointer concept is much more good than the counter variable concept because we can solve it just in n by 2 time complexity. So do you have any other approaches, anybody?
I mean, I think these are all the very efficient approach. Inefficient is like put everything in the another data structure and then get the middle. And those are not anyway efficient.
Yeah, but if we will add like push into some array and all, then we can't return the node, I guess. But we can just return the value part of
And in
the
this
node.
case, we will basically we'll have a node pointer in that whatever
Okay,
data structure. It's not data. Copying
okay.
data is not a good solution, but I think those are not anyway yeah good solution. So this whatever we have discussed, that is good enough. One thing to add is that the uh, fast and slow pointer is that technique is useful, because if somebody tweak the question and say that return me the fifth from the end, or written those kind of question. If the question is tricked a little bit, that all can be solved with the fast and slow pointer,
Yeah, sure.
right?
Yeah.
One
So
of the
yeah.
one of the variant in this question which I was thinking was around if there's an even number of elements and you want to return the first of the middle ones. Right now in this case we are saying if there are two
Yeah,
middle
I
ones, then
got you.
return the second one.
Yeah, that would be a nice question, sure.
We'll use the fast and slow approach only, and we just have to keep a previous node, right? Wherein I'll return the previous of my slower node as the output every time.
But for that, I guess it won't work for the odd number of nodes. Like if you will return the previous one.
No, for the fast and slow pointer, I think then the case will be uh, before you increment the slow pointer, you have to first ensure that the entire fast pointer is complete. Like if you have 5 elements and your fast pointer is not able to complete its 2 hoops, then you just don't update the slow pointer. So for the first one, you have to, if you are trying to find the second middle, then you can first increment the slow pointer and then go with the fast pointer, even if it's not able to complete the 2 steps. But if you want to find the first one, then probably you might want to first check whether the both fast pointer, 2 steps for fast pointer are available. If they're available, fine. If not, then don't increment the slow pointer.
Rather than
Probably
checking this much amount of stuff, just keep a Boolean operator like I did. Just keep a flag which gives me true when I'm at the even junction and gives me false when I'm at the odd junction. It's fairly simple. I'll check it out that if it's even, then if it's true, then I'll have to return the mid, and if it's false, then I have to return the mid -1.
Yeah, that would work.
Linked list, how will you go back? Mid
Keeping
-1.
a previous node, right? I already told
We
you.
will use an
Okay,
auxiliary
so yeah, that's fine.
node. Yeah.